You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everyone. Bob Keane here, your host of Fire Ecology Chats. Fire Ecology Chats is a kind of a program that we talk about a recent paper that was published in the journal Fire Ecology. For those of you who don't know, Fire Ecology is a journal that's published by Springer, but it is run by the Association for Fire Ecology. Today, we have a very special person and a very special paper we're going to talk about. The paper is Complex Effects of Fire Severity on a Serotinous Conifer. And the person we have here is Kyle. Kyle, you want to introduce yourself?
Yeah, hi. My name is Kyle Merriam, and I'm a recently retired employee of the USDA Forest Service. So really excited to be here today to talk about this work.
Kyle, whatever possessed you to write about serotiny and Baker Cypress? Could you give us a quick thumbnail of what the paper's all about?
Yeah, Bob. Well, this is a really exciting paper for me. I actually first started working with this species in 2006. So kind of right at the start of my career with the Forest Service. And when I first started working with this species as an ecologist for the Forest Service, we were really interested in trying to figure out how to reintroduce fire to our California ecosystems, which, in 2006, we still were really under this legacy of fire suppression. We had very few fires that were burning naturally. And I was really interested. We knew a lot about how it was affecting our vegetation types that are adapted to frequent low severity fire, but we didn't know a lot about how fire suppression was affecting species like Baker Cypress that require high severity fires at long return intervals. So I started this work in 2006, and here we are in 2026. And things have really changed a lot for not only Baker cypress, but most of our vegetation types here in California with this extreme alteration of our fire regimes. And I think this study just provides a really interesting overview about how altered fire regimes have affected species and vegetation types that are adapted to high severity fire. So I'm really excited to share this work with everyone.
I guess you could say this paper is a summary of your life work. That's really cool. That's reason enough to read it. Is there anything special about the methods you want to talk about?
Yeah, I think we just had this great opportunity. In 2006, I was able to go and visit 10 of the 11 known populations of Baker cypress. So Baker cypress is just a very rare, one of our endemic cypress here in California, one of only 11 species that occur here. Of course, there's only 17 species of Hesperocyparis, our New World cypresses in the world. We have 11 of them here in California. Baker cypress is one of the more rare New World cypresses. And in 2006, I did a status survey of 10 of the 11 known populations, and we found that most of these populations had not burned. We were really worried that without fire, they were going to get wiped out. They were going to become extirpated, because these serotinous species with these closed cones, they need fire in order to reproduce. I was able to do that pre-fire work in 2006 and get an idea of what these populations were like prior to fires. Of course, at that point, our recommendation was we really need to burn these populations. None of them are reproducing. Let's get some fire out on these landscapes. It didn't take long. In fact, it was the very next year in 2007 where one of the populations burned completely in a high severity fire. And since that time, most of the other populations have burned. Now over 50 or almost 60% of the populations have experienced high severity fires. So the situation has really changed for this species. And we were able to go out immediately after these high severity fires and collect data on both fire severity as well as post-fire germination rates and seedling densities. So we were able to look at 4 of these populations immediately after fires. And then over the course of as long as 9 or 10 years, we were able to follow 2 populations over time and really see, how they were recovering from these fires.
That's great. Yeah, it's a wonderful paper. And if you don't mind, I was wondering if you'd let us peek under the sheets and give us a little nibble of what the results are.
Yeah, well, it was really interesting and actually really surprising for me. We think that with this increase in the extent and severity of fires, that at least vegetation types that are adapted to high severity fire should benefit, right?
Yeah.
We know it's having negative effects on vegetation types that require frequent low severity fire, but you would hope that at least a vegetation type that needs high severity fire effects would benefit from high severity fire. So we were really surprised surprised when we found, and I think we were really only able to detect this because we could go out in the field right after these fires, that there were actually negative effects in fire severity.
Wow.
Yeah. So it looks like even our high severity fires have been altered by fire suppression, and that we're now seeing fire intensities, or at least we infer that from the severity metrics that we were measuring, are kind of beyond the range of what these species have evolved to benefit from. So I think we're seeing changes in even how high severity fire operates in these vegetation types.
Serotinous species, and you have negative effects of fire. So what's a manager to do? What's the management implications?
Yeah, I think that really the management implications are the same that we have for all of our vegetation types here in California. And that is that we need to restore these natural fire regimes. And restoring fire regimes in low severity adapted vegetation types will help to restore the fire regimes in the high severity types. These vegetation types don't occur in isolation. They're part of the same landscapes. So I think it's just the same accumulation of fuels coupled with the drought and changes associated with climate change that are causing this increase in high severity fire. So I think if we can do things to moderate or mediate fire effects across the landscape by addressing fuels, stand densities, and other factors across the landscape, then we can help to restore fire regimes across the range of regimes that occur in California.
That is so well said. And that is true for a lot of our fire adapted species. So thank you. Thank you for coming on and telling us all about this wicked neat paper. Do you want to recognize your co-authors or funding agencies?
Oh, yeah, definitely. I'd like to recognize my co-author, Kirsten Bovey, who worked with me for many years on this paper. We also initially received funding for our surveys in 2006 from the Joint Fire Science Program. And I did that work in collaboration with Aaron Rentz and Max Creasy, so I would like to recognize them. I'd also like to recognize Dr. Jeff Kane at Cal Poly Humboldt, who has been collaborating with me on work to address the conservation of Baker Cypress for a number of years, and I hope that we can continue to collaborate.
Well, you just dropped the name of a new editor of Fire Ecology, so you can get your paper published anytime. Hey, and I want to thank you for coming on, and it was wonderful to talk to you, and thanks for dedicating your time. For those of you who like this paper and think you'd like maybe a read, guess what? Kyle has paid all the freight for you to go ahead and read it, so you can download it for free from our website, the Fire Ecology website. With that, I'd like to invite you to tune in later to another Fire Ecology Chats.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. fireecology.org.